So what I'm doing, I'm applying this. Whenever we have log of a to the base b, it can be written as log a over log b to any base. Right now, base is not important. You can take any of your choice. Okay. So by applying this formula, I can write the first term as 1 over log x over log 2. That log 2 will come up. So similarly, all of the log terms, like log of constant terms, they will come up, and in the denominator we'll be having log x only. So this is the first step. Just have a look at it. If this is clear, it will help us a lot in going ahead in the question. Now the next step is, before actually going to find the common difference, we need to process it a bit. So what I'll do, first is log 2 by log x. I can't do anything, but the other one, 8, can be written as log of 2 cube. So it will be 3 log 2 over log x. Then it will be 2 to the power 5. So that will be 5 log 2 over log x. And then 7 log 2 over log x. So from here, it is pretty much clear that log 2 over log x is a repeated term. It's a constant repeated term. So this is same as a, 3a, 5a, 7a, and so on. It is same like that. Okay. So now we can work on the common difference, and then we'll write down the formula for sum of.
Yeah, you wrote yeah, 3.
Okay, what can we do after this? Okay, so for time being, I will be treating a as log 2 over log x. Okay, this is an optional step. If you don't want, you can directly get ahead with this, but that will be difficult. So best is to do like this. Now for this series, sum of first 20 terms is 100. Sum of 20 terms, so it will be like S20 is equal to 20 by 2, 2a, 2 times a. A is the first term plus 20 minus 1, 19. D will be 2a. I'm just finding the value of sum in terms of a. 2a plus 38a, that will be 40, and that will be 400a. And as per the question, that is equal to 100. So this is equal to 100, and that will give me the value of a as 1 by 4. Till here, we can work in terms of a. And now we can put the value of a as log 2 over log x is equal to 1 by 4. Cross multiplication will give me 4 log 2 is equal to log x. 4 can go in the power. 4 can go in the power of 2, so that will become log of 2 to the power 4 is equal to log x. Taking anti-log on both the side will give me x is equal to 2 to the power 4, that is 16. That's it. So if there is any doubt, anyone, you can ask. Okay, by applying the base change formula, that will be log 3 over log 2, log 4 over log 3, log 5 over log 4. It will go on. I'm just writing the second last term so that it will be convenient to understand. That will be log 31 over log 30, and then log 32 over log 31. So from here, it is quite understood that all the terms will get cancelled except log 32 and log 2. Rest every term will get cancelled. So I will be left with log of 32 over log 2. Log 32 is 2 to the power 5, so that will be 5 log 2 over log 2. 5 will be only leftover term, and the value of a is that only. Why everyone's camera is off today?
So today I forgot my laptop charger at school, so I have to use my phone. And if I turn the camera on, it will be like extremely awkward angle. So
Okay.
So for me, it's connection.
Okay.
Like it's laggy when I turn it on, but I can turn it on.
oh yeah, listen, why weren't you here at school today? Is everything alright?
Yeah, I was ill today, so I didn't come today.
Okay.
Okay. Anyone have any doubt in how we got 5? Rajveer, any doubt?
No, sir.
Rajveer turned it off by looking at them, is it?
No, sir. I had it on, but then the previous question became blurred, so that's why I turned it off, and then I forgot.
Okay. Okay. Let's move on to the next question. One more question of log. Solve the equation, express your answer in terms of ln2 and ln3. So 2 minutes for trying, and then I'll.
3
Okay.
times x minus 1, and we can write 6 raised to 3x as 2 times 3 raised to 3x. From there we can write 2 raised to 3x times 2 raised to minus 3 is...
Can we directly take log on both the sides from here? That will be easy, na?
Okay, yeah.
Okay, directly, this is fine. This step is absolutely correct. From here, directly take log. So that when you'll take log, na, these powers will automatically come in front, and it will be easy for us to deal with the remaining part. Rajveer, is that clear?
So could you repeat that again?
This step is clear. What is written?
Yeah.
Okay. After this, I am saying that we need to take log on both the sides. Now, since they are saying express your answer in the form of ln2 and ln3, okay, so we'll take log to the base e. So taking log to the base e on both the sides. Raghav, was there any other method you were doing or same?
No, sir, it's the same. And then see, we can take the other thing down there. Yeah, yes, it's the same thing.
Yeah. Okay, so in the left-hand side, it is quite sorted that whole 3x minus 1 will come in front and ln 2 will be left. Right-hand side, first we are going to apply the property of ln AB. That will be ln A plus ln B. So ln 2 to the power 3x plus ln 3 to the power 3x. And then it's just we need to solve it like a regular question. So 3x ln 2 minus 3 ln 2 is equal to 3x ln 2 plus 3x ln 3. Now this 3x ln 2 is there on the opposite sides. You can take it on one side, it will be cancelled. Okay, so we'll be left with, now we need x value. Okay, so x value, so how we can do it? We can just, okay, we can further divide everything by 3. So this 3 will also be gone. And now I have minus ln 2 over ln 3 is equal to x. We can leave it in this form. Okay, like you need not take that minus inside the log. You can take it, that will become 2 to the power minus 1, but it's okay. We can leave it in this form. So in any of this step, you can see if there is any question, you can ask. And if it is done, let me know. We'll move on to the next question. Is it done?
Yes, sir.
Rajveer and Raghav, is it done?
Yes.
Yes, it just.
Done? Shall we move on?
Yeah.
Okay, now the next question. First, I will explain, then I'll give you some time to try, and then we'll discuss it together after some time. First three terms of geometric sequence, they are given. Okay, it is in the form of trigonometric terms. Find the common ratio R. There will be few formulas of trigonometry which I'll be directly telling you over here. Okay, it is not needed for this question, but anyways, we need to do it later. So I'll tell you now only. Okay, first part is find the common ratio R. It can be managed very easily. You need to just take the division. Okay, like sine 2x by sine x. Then next is find the set of values of x for which this series converges. Now, what is the meaning of this? So normally, okay, have any one of you heard about damped oscillation? Okay, let us understand one thing just for general knowledge. It will come like, I don't think so. It will be there in physics also because that is there in IITJEE syllabus. You guys will be having only normal oscillations in physics. Okay, so this is the curve of sine. Okay, we know that it fluctuates uniformly like this. Okay, so it's like an oscillation only. Now what happens? Just imagine Rutherford's experiment. Okay, everyone knows what was done in Rutherford's atomic structure experiment. He said that like it was a gold foil experiment. He just passed alpha particles to the gold foil. Okay, and he just gave one conclusion that electrons are revolving. Later on, Bohr was the one who explained that if electron will revolve, they will lose the energy, and then finally they will merge into the nucleus, which will put a question mark on the stability of the atom. That's where Rutherford's model got failed, and Bohr's model was used later on. Okay. So the same thing is happening over here. Just imagine that these are the electrons which are moving in this trajectory and they are continuously losing their energy. So don't you think that the peaks of this graph will continuously reduce? Everyone can think like that. If like this is the energy graph of an electron, okay, it is totally out of context, but you will understand. It's a correlative example. Okay, so this is an energy diagram of the electron, and electron is losing energy continuously. If it will lose energy continuously, then the oscillation of electrons will be gradually, it will come like this. Okay, I'll just make a proper graph. What is the meaning of damped oscillation? So it will just go like this. Okay, this is called as damped oscillation, that continuously someone is losing energy. Okay, the same thing is applied in this particular series. They are saying that find the set of values of x for which this converges. The whole story I am doing because of explaining this term, what is the meaning of converging series. So converging series are the one whose infinite terms are almost equivalent to zero. If you want, you can write this thing. Convergent series. There are two types of series. One will be convergent, one will be divergent. So whatever we are writing for convergent, it will be just opposite to that. So if it is converging means at infinity, the terms will have negligible value. The value is almost reducing. One more example I can give. For a geometric progression, let's say I start with 1, then 1 by 2, then 1 by 4, then 1 by 8, 1 by 16, and so on. You can see that gradually the value is becoming very small. And at infinity, this series will have a zero value. The term of that series will have a zero value. Okay. So for such type of series only, we can find the sum of infinite terms. And now comes the conclusion. The series which is convergent, the condition for that is the value of r should be greater than 1. To be precise, the value of mod r should be greater than 1. It means if the r value fluctuates between -1 to 1, the series will be convergent series. If it is greater than -1 or greater than, if it is less than -1 or greater than 1, then it will be divergent. Now, if anyone have any question, first you can ask the question, then we'll start with the question, this particular question. Okay, if it is fine, then question is open. In the question, there is one more thing which you should know. Okay, that is a part of trigonometry, so let us just discuss it now. There is one formula of sine of a plus b. Okay, these are the formulas which we will do in trigonometry. Okay, we are doing few formulas now. Sine of a plus b is sine a cos b minus, no, plus cos a sine b. Let us write capitals because these are representing angles. Okay, just write this formula. Eventually, you need not learn the formula, you should just know how to apply it. So sine of a plus b is sine a cos b plus cos a sine b. Now, if a is equal to b, then the same formula will become sine of 2a. If I replace everything by a, I will get sine a cos a plus cos a sine a. These are same terms only. So that is why it can be written as 2 sine a cos a. This is like a very important result which can be used in physics and maths both. So you will get this term in the question. You should simplify by putting this value and get the actual value of common ratio. Now you can start with the actual question. Sine 2x over sine x. Sine 2x can be written as 2 sine x cos x over sine x. Sine x will be cancelled. The value of r will be 2 cos x. That is the answer for part A. Part 2 is find the set of values of x for which the geometric series converges. Now we have already seen that when it converges, it means that mod r is less than 1. This is the condition. So r will be between -1 to 1. Now what is the value of r? Just now only we have found the value. It is 2 cos x. I'll put the value of r over here. So I'll get 2 cos x between -1 to 1. And that will give me cos x between 1 by 2 minus 1 by 2 and 1 by 2. Now what should I do from here? You can take cos inverse on both the sides. Okay, when you take cos inverse on both the sides, okay, just try it out. Cos inverse of negative 1 by 2 and cos inverse of positive 1 by 2. There is one more thing which you will understand over here. Just find the value of both of them in calculator.
So it's 120 and 60.
120 and 60. So like from those values you can see that 120 is coming first and then 60. So from here there is one more conclusion which we can understand. Whenever we are taking inverse, like there was one property of inequality that if it is, let's say, minus x is greater than 1. So you are multiplying by minus on both the sides, so it will be x less than minus 1. Similarly, cos is a decreasing function. Okay, cos is a decreasing function. Evidence is the graph of cos. Okay, so because of that, whenever we are taking inverse of cos, we have to flip the sign of inequality. That will be applicable only in terms of cos. If it is sine, it will not be. And I'm not saying that you should remember this, but when you will actually find the value now, from the value it should be clicked that if values are coming opposite, like 120 is coming for this and this will be 60. So from there it is quite understood that the sign of inequality should be flipped. So my final answer will be x lying between 60 to 120. And for the last part, you need to consider this x is equal to cos inverse 1 by 4. Show that sum to infinity is this. So sum to infinity is a over 1 minus r. Okay, is there anyone who is writing from here?
Yes, sir, just a second. So I just have a small question.
Yes.
When we do like, for example, when we did minus 6 greater than 1, why does it like the sign flip when you like multiply it?
Okay, look, that usually happens because of the nature of the function. Okay, like we haven't gone into detail of that. Like I'll just give you a small glimpse. There are two types of function, even and odd.
Yeah.
Okay, it can happen with this also. There are one more category of function where we call it as increasing and decreasing function. Okay, so we haven't done inverse trigonometric function yet. Okay, like when I talk about cos inverse, okay, so cos inverse is a decreasing function, and for a decreasing function, whenever we are dealing with inequality, we need to flip the sign. Okay, now this is not a rule, this just came out of the observation. As I was saying that first you see that this is 120 and this is 60. So our observation itself is suggesting that no, the sign of inequality should be flipped. Otherwise, it will be logically incorrect.
Okay.
Are you understanding? This is not
Yeah.
a rule, but this just came out like that. So then we made it a rule. Okay.
Okay.
I am saying that no need to remember it. If you want to learn it, then it will be applicable always whenever we are dealing with cos. When you take cos inverse, the sign will get flipped. Okay. This
Okay.
is a fact which usually teachers say that you should learn. I'm saying not to learn. Okay. You just observe on the spot and use your general understanding and flip it. Okay. For some, if it is not changing, like for example, for some, if it is in the range of, let's say, 80 to 120, in that case, we will not flip it because 80 to 120 is like from smaller to larger.
Yeah.
Okay.
Okay.
Okay. Last part. Show that sum to infinity of this series is this. Okay. So sum to infinity is a upon 1 minus r. A is sin x and r is
2 cos x.
2 cos x. And consider x is equal to this. So this we need to put it over here, then only we'll get the value. So x is cos inverse of 1 by 4. It means cos x is 1 by 4. If cos x is 1 by 4, sin x will be 1 minus cos square x inside the square root. So that will be 1 minus 1 by 16. That will be root 15 over 4. Okay, how I got sin x and cos x value? That was given in the question. We need to use that. Okay. We need to just plug the values now. So finally, after plugging the value, it will be root 15 by 4 upon 1 minus 2 times 1 by 4. 1 minus 1 by 2 will be 1 by 2. So that will be root 15 by 2 on calculation. That is what they were asking. Okay. So this is possible only when we are using this condition. Okay. Still, you can go over it one more time. Okay. Try a few more questions from the same website, which I was saying. Next Wednesday, like next class on Thursday for maths, we will be doing some more questions on trigonometry. So gradually we will just move on to that topic now. Okay, I'll be taking more questions connected with trigonometry from unit 1 and then we'll switch on to that topic in that process only. Okay, so see you on Thursday for maths. Tomorrow classes are at usual timing 6 to 7. Okay, Thursday's time we will decide tomorrow. We'll finalize it tomorrow only.
Okay, sir.